We aren't talking crap. We're just stating facts.
All right, so we're talking about conic sections. You've heard me kind of mention that, but now we're learning why they're called conic sections. They're formed by intersecting a plane with double naked cones, which should have an S at the end of that. I don't know why I didn't put an S. And so you see those cones sitting on the card up there. So one little display I get to use.
Those are fancy.
Yeah. I get super excited. It's not that exciting.
Do you just look at them? That's it.
They come apart. I'll show you some things, but it's still not super exciting. There's also a video, but we'll wait until tomorrow or Friday to look at that.
Ellie's not here for lunch today, Madison.
It's just me and you.
You guys have to sit at the same table all the time.
No,
Still.
we have assigned seats.
I thought maybe that went away.
No,
we
it
can
definitely
sit outside.
did because people moved to my table that didn't sit there before.
Guess what? We get to sit outside
You
today.
get like periods where you can switch. Now they're like a little bit more relaxed on it, but
Why do you get to sit outside?
Oh no, they said we could.
yeah, they said tomorrow we can if we want to.
Today.
Speech.
Tomorrow. They said tomorrow yesterday.
I mean,
Oh, today's
Yeah,
supposed
that's
to
what
be
I'm
Wednesday.
I missed a section of the sections.
Will anyone see Brooklyn or Layla tonight?
Yeah, we're hanging out.
Are you?
No.
I'm pretty sure
I
she
sense-
might live in my neighborhood.
She does.
Like her mom or dad.
Who, Brooklyn?
Not
Yeah,
planning
her
on
mom
seeing her,
does.
So
Yeah.
we'll
Her
just
mom
wait.
lives in your neighborhood.
Yeah, because Jalen lives next to her.
We'll
Yeah,
just wait
Jalen
till
does
tomorrow.
live
We can get that.
Her little
Jalen
sister,
does?
yeah, her little sister always drives on the
They
golf
live
cart
right
and
next
waves
to
at
each
me.
In your neighborhood?
Because Jalen used to live like across the street.
All the kids have golf carts in my
But
neighborhood. They
Really?
drive them around.
I rode the bus with Jalen.
Alright,
Okay, I'm excited for
Oh my
this.
Well, this is super exciting.
I have to draw that?
No, it's a
What made
display.
you think that,
If you
buddy?
really want the picture, you could look on the Google Classroom on page 649.
No, I thought we were like making graphs.
You do
with
not know.
those.
You don't have to draw this. So here's what a double naked cone is. It's a cone, two cones. It's two cones tip to tip.
It looks like that peanut thing. It looks like the peanut.
Oh my gosh, from
Yes,
chemistry.
yes, it looks like the
That's
peanut.
a shape. That's a shape, an orbital shape. It's a peanut, and there's a double peanut that also looks like a flower.
So I should talk to Mrs. Malott about this.
No.
Spare yourself the conversation.
I'll talk to her about it. Okay, so what happens is, so this is three-dimensional, right? Obviously. So then I'm going to take a plane. A plane is like a piece of paper. And I'm going to slice it through there, and I should be able to get the four different types of conic sections which are parabolas, ellipses, and hyperbolas. So go ahead and write those down. And then we'll see if we can get all four of those. And we got into the whole discussion last period, well, why? And well, I don't know why they had these two naked cones, double naked cones to begin with. I don't know why they were exploring these things, but maybe it relates to whatever you're talking about, this peanut thing. Maybe it relates to that. But this is what relates these four shapes together, these four graphs together. It makes them, remember how we've talked about families of graphs? So that's what relates these together. So when I talk about lines, they're not related because I can't get them from this. Next year you're going to learn about sine curves, cosine curves. Ooh,
Can't wait.
those are fun, but they're not related to these because you don't get them from something like this. But I can get all four of these. So if I look at, so hard to do. If I look at this and I take a piece of paper and I slice it through just the top of this cone, what do you think it's going to make?
A circle.
Is that a
Oh
circle?
my gosh. No way. Holy moly.
Okay, so let me set that down because that's heavy. So now if I still go through just one and I slice it this way, it's just gone through one, what do you think it's going to make?
So it is.
Is
right?
it?
Yeah.
It is. Okay.
Yeah.
It kind of looks a little circly, but I
That's
can
a
tell.
ellipse. But an ellipse is just, or a circle is a special type of ellipse, but this is an ellipse. If I hold it this way, is that a little bit easier to tell? It's an ellipse? Okay. What else do I need?
Parabola.
And the hyperbola.
Okay. I need to throw the hyperbola in there.
Sorry.
So if I look here,
You just dropped the ellipses.
I love your demonstration.
thanks. Is this like Mrs. Malot's demonstrations?
Yes.
Yeah, it's working out better.
Where did I put the matches?
It's
Normally
more like,
you should
I don't
have
think we should
goggles,
do
but I'm
this.
not gonna wear them for this.
She was like, do you need a explosive shield in front of you? For like,
Probably. Let's just put one there.
She
just
did that
in
in
case.
thing. She was like, everything is telling me not to do this. I'm gonna do it anyway.
Yeah, she's
And
like,
that's
we'll
when
put
she-
it behind explosive shell.
She was like,
That's when she told us about her fear of a branch slicing
I
her.
wondered how that came up. Alright, so if I put my paper through both of these, can you see the lighter sections?
Mm-hmm.
And so the lighter
Parabolas.
sections, I'm not gonna try and take them off and hold this. The lighter sections,
Parabolas.
or if I'm looking at both of them,
hyperbola.
those are my hyperbolas, right?
Wait.
We already had one of those.
No, we don't. We have circle and ellipse.
Oh,
So if I look at both of them,
Oh,
if I look at both of them, it's a hyperbola. But if I just slice through one, so if I just slice through one cone, it's a parabola.
Oh,
Okay, so that's all four of them.
crazy.
So is that where they
I'm
all
gonna
came
stretch.
from?
So that's where they all came from. So that's how they're all related. That's why we talk about them all together.
Yeah, you had to cut stuff.
Okay.
Not really.
This was passed down to me from the last math teacher that retired, so I feel as though I have to use it.
That's so cool.
Some of your siblings had
Oh
it
my
in the
God.
flavor.
Ancient.
I don't know.
Caroline
A
has her
student
friend
gave it to
too.
her. A student made it and gave it to her. I feel like it's my duty to use it every year.
That's impressive.
It's kind of impressive, I mean.
It's very shiny.
I'm so impressed
Solid
by that.
wood. Could sell it on eBay to another math teacher.
I was gonna say it's a lot, not very high demand.
It's
All right.
cool though. That's cool.
It is neat.
Are you gonna give it to the next math teacher?
Maybe.
Might
20
not be,
years.
You never know. Just kidding.
All right, let's switch to our pink paper. We're gonna start filling that out, and I wanna start with the ellipse. We're gonna say the parabola we probably won't get to until tomorrow. We'll start with the ellipse. I think the easiest way to do this is to have the form with the center at 0, 0 kind of off to the side, and then to go through and put the form where it's been moved or where the center can be anywhere. So off to the side here, do a color you can see, I'm gonna put the form where the center's at 0, 0. So what does that look like when it's horizontal for an ellipse?
Sorry,
Squared.
I was not thinking.
X
That was a
squared,
lot of talking for you.
and then over A squared, and then plus Y squared over B squared.
Yep, I just need to make that thinner.
Equals 1.
Wait, why are you putting it up there?
I'm just putting it off to the side because here I'm gonna put, this is just the special case. Here I wanna put, okay, this is for any case when it's moved. So make this one a little bit smaller. Then I'm gonna put a couple things up here for the ellipse that's true for both the horizontal and the vertical. What do you think I'm gonna put?
It's a list.
It is an ellipse. What were you gonna say?
C squared equals A squared minus B squared.
Yes. So we'll use that equation for either one. Something else.
Addition.
You could, but I think I get that from my equation. Something that helps me distinguish between the two forms.
When the Y squared is first, it's up and down.
No.
Why A squared is bigger than
So
squared?
A is always bigger. That's what I was gonna put up here. So A is bigger than B. Or A squared is bigger. You can put it either way.
The Y and X don't change on this one, do they?
They do not. If you want to put that on the top, you can, but I probably don't need that. I think that is encompassed with this part. So again, this is the special case, so I'm not going to put this stuff on the line. I'm going to leave that blank. I'm just going to put it under because it's the special case. So right now, what we've learned is when the center's at 0, 0, so it's going below the line, because this is just a special case. Where are the vertices?
Plus or minus X is X equals 0. Plus or minus A. 0.
Where's the A go? Yeah. So the A goes in the X position. So plus or minus A0. And again, put that below the line because this is just your special case. So the co-vertices are in the Y position. And the foci are in the X position. Is that kind of coming back to you now?
Yeah, I didn't know what you were asking.
I hope that was why.
Open the window.
Sure.
Me too.
You two what?
I'm hot. I feel like
Job.
it's colder than
Then it is out there.
I'm glad you were watching me.
It's so cold and so disconnected, and I can hear my face sweats off.
Sorry.
Miss Murphy's class.
All right, let's also do this one. I think that might be a little easier. Let's also put, if you want, some of you may not need it. I'm gonna put that this is the horizontal one. Some of you may know that and don't need it. This one, then the below one, let's put it's the vertical. And then let's also put the special form for the vertical. So what changes?
The A and the B.
The A and the B switch. So it's still x squared, but now it's over b squared plus y squared over a squared equals 1. So the center is still 0, 0. And again, I'm putting this below the line. The vertices, it's still the A, but the A is in the Y spot. So 0 plus or minus A. Co-vertices, plus or minus B0. Foci, 0 plus or minus C. Okay. Now things are going to start moving.
Uh-oh.
Dun dun dun. For a moment, remember this. So this was for a parabola back in the beginning of the year. What was the H and the K?
Vertex.
It was a vertex. Which did I take the opposite of?
H.
So I took the opposite of H. We kind of thought because of the parentheses, but that wasn't the real reason. The real reason was because... What do you mean?
It's minus.
So because it's minus, and because when I pull it out, I've set it equal to 0, I think it's x minus h equals 0. So when I solve it, it's h equals 0. So yes, you're both right. So I always take the opposite sign if it's something like that. Well, here's why that comes into play, or why I'm reminding you of that. Here's what standard form looks like. It's x minus h, that's similar, squared, over a squared, plus y minus k squared, over b squared, equals 1.
I need my hand out on this.
For every single form, every single graph on this pink sheet, so parabola, ellipse, hyperbola, circle, they use h and k. And every single one in the formula is going to be subtraction. So for every single one, when we pull it out, we have to take the opposite. So some of you may, on the very top of your sheet, might want to put that you always take the opposite of h and k. Always take the opposite of h and k. And that's for all the different forms. And that's because in all of these standard forms, it's always in parentheses and it's always subtraction.
Wait, so for like everything?
So for everything. That's why I say, and you can put it in every single box if you want. I don't care. But I just said, well, instead of writing it every single time, maybe just put it at the top of the pink sheet altogether. So now, when I look at the center, I'm going to pull out the h and the k. So the center is hk. And we're going to see examples, so don't write this down. But if I had something like x minus 2 squared over 4 plus y plus 7 squared over 10 equals 1, the center would be 2, negative 7. So that's what I mean by pulling out the opposite signs. Are we okay on that?
We're not.
I don't know, that's scary. All right, so now this is gonna look weird, but it really it's okay once we start getting numbers in and we start getting practice with it. It will be okay.
Wait, I
Oh,
just
the plane?
remembered
Yeah, I
something.
was talking about mom, but
What?
Are you the shoes that you said you're getting a Breeze? Are they the white ones with the red Nike on?
Yeah.
Those are volleyball shoes.
Well, I don't care. I like them.
I
Does she know they're volleyball shoes?
don't think so, because her mom got them for her. But
Yeah.
my whole team, we all had those for.
Oh,
our
those are
volleyball
nice.
season.
I like them. So would I be stupid if I was wearing them?
I mean, kinda. They're really made
Look
for
'em
like
up.
they're
Look 'em
they're
up. I
made
wanna
like
see
for
'em.
track.
If there's time at the end, I will. All right, I won't get those, but I might get Alex Rumpin shoes.
I like those.
Those
I think
are
I know
football
what you're
shoes.
talking about. The
Just
ones,
kidding.
Not.
the ones that are like really colorful.
Yeah, he hasn't worn them recently, but yeah.
You want my shoe? My boot?
I already have a couple boots. I don't need another one. I have a taller one and a shorter
We
one.
can all wear them in match.
She can wear.
We
she can wear
could.
one on each foot.
Ah,
I'll come
that
to my
would be a
final
style.
spirit class as long as you guys come in boots.
Okay.
Because
Do it.
me and you are opposite foot, so I could give you mine and you could have two.
I'll have.
Okay.
I don't have any.
I meant
All right,
we could
here
wear
are-
them both together.
Here are vertices. So the vertice, it affects the x position. But right now, the x is h. So we have to change the h, not just 0. So it has to be h plus or minus a. The y value stays the same. So the y stays k. Already lost Zoe.
Yeah, I'm definitely lost. I was
All right,
lost from the
It will
beginning.
be okay. The co-vertices, the x value stays the same. So it stays h. The y value changes, k plus or minus b.
I really am just gonna.
The
not-
foci, what's going to change, the x or the y?
H. I mean, X.
You're right, the x, which is h, plus or minus c, k stays the same.
It'll make sense.
With numbers, it helps. And we're going to finish this column. So we're going to do the vertical one, and then we're going to go and graph instead of doing the whole sheet and then trying to go. So we're going to do one of these graphs today. All right, so we've got let's go down to the vertical. We've got the standard, or we've got the special case. Let's do the standard. So it's x minus h squared over b squared plus y minus k squared over a squared equals 1. So that looks very similar.
So, have you memorized? Like, could you memorize every single?
Well, that's a fair question. So I was telling the other class, so what happens is, we didn't do this last year because of the pandemic, so I pull this out this year, I don't do it with my other classes, and I look at it, I was like, oh, shoot.
you
Like,
did?
this is a lot of stuff. I don't have it memorized. But when I go to look at it, I'm like, okay, oh yeah, this is how it works. So now, if you ask me to do this, I have it memorized, but it's not even necessarily that I have it memorized. I've learned, okay, this is how these things are related. I know that, okay, this affects the x position. So I know, okay, I'm going to change the x, and then I know it bounces back and forth.
But you're a lot smarter.
I don't know that I'm a lot
And you
smarter,
teach it, like,
but I
3
know
times a
that
day.
I have gone through it several years in a row. So yes, I do have that advantage. But I also have the advantage that I've gone through it, so I know what people struggle with and what they don't, so I'm trying to help you.
With this handout on our test.
Now, we're going to have a quiz and a test. We kind of figured that out last period. We're going to have a quiz on Monday, test on Friday. I am going to let you use this for the quiz, but not for the test.
Sound like a donkey there.
I did eliminate some of the material for the quiz. The quiz, we were also going to learn how to write equations. We're not going to try and squeeze that in before the quiz.
I've only get to use it on the quiz for the first 5 minutes.
No,
I mean the test. I mean the
No.
test.
I was like, Bailey,
All right, we got to keep going here.
God.
I know. I was like, you're making it harder
She's
on
like,
yourself.
I want it to be challenging.
All right, so here we're going to keep the h. K stays, or k, we're going to make it
Plus or
k
minus
plus
A.
or minus a.
Oh.
Co-vertices, it's h plus or minus b. K stays the same. And then here, h stays the same. K plus or minus c.
Remember we do stuff like that? Then like makes
Hold
it
on,
really
I messed it
confusing.
up.
It makes me seem really smart. Like if other people look at
Right,
this, they
that's-
say,
don't you feel
"What the heck?"
Like
successful
people
then?
in
Yeah.
geometry, I'm like, hey,
Yeah.
you have to go cool.
Yeah,
Like in the other algebra classes?
Big long equations
Yeah.
with like the
Right.
long division and stuff
Yeah.
with it. Like
I'd be like, yeah.
Alright, go to your graph paper.
Hold on, I'm not writing this down.
Okay, I haven't switched. We're gonna do number 1, because number 1 is an ellipse.
Oh. Wait, which one?
Number 1,
This is all
example
we're
1.
putting in these notes.
Well, so you can decide if you want to put your work on the graph paper, you can. If you'd rather put it on your notebook paper, that's up to you. So, otherwise, yes, that until we write equations, which we might get to next week, that's all we're going to put on there.
Okay.
All right, so whoops, too far. There's my ellipse. So it's equal to 1, good to go. So I need the center. Well, let me back up. Let's find the A and the B and the C first. Why don't we do that? So the A or the A squared is always the bigger number, so it's the 16. So is this horizontal or vertical? Horizontal, good, because it's underneath the x squared. So A is 4, B is 3. And I think it's a good idea to list your A and your B. If you don't, that's okay. You do need to show me getting the C squared. Do I add or subtract those? Good.
Subtract.
Oh, yep, good. I said good too soon, didn't I? Subtract those.
What?
Subtract. We do need to subtract. Square root of 7. I just trusted you were going to be right. 2.6.
Did you do your trick?
She's still thinking.
It's not working.
All right, so now we have to be careful. We do need to list the center. So we're going to have center, vertices, co-vertices, and foci.
That's gonna be one of my problems is knowing, like, because
Yeah.
the ellipse goes with certain things, and you know what I'm saying.
Well, and the ellipse and the hyperbola, I think, are very similar. If you accidentally, on the hyperbola, if you name the points the co-vertices, I'm not going to take off for that. So those are really the same. And the parabola is just its own animal, and the circle is just the radius. So I think once you get into the habit of it, it's not as bad as it does seem overwhelming. I get that. All right, what's the center? 2, 1.
Good job, Zane.
Taking the opposite. Okay, here we go. So, just break it down into parts. What's going to get affected, the x or the y? The x is going to be affected because it's underneath that. So I'm going to do 2 plus or minus the a value, which is 4. The y stays the same. I'm going to leave it like that for a minute. I'm going to come back to it later, but I'm just going to leave it like that. Yeah.
Okay, why is it on the x again?
It's on the x because it was under the x squared. The bigger number was under the x squared. That's where the a was. All right, so then, remember, I'm just kind of bouncing back and forth. So the co-vertices are going to affect the y. So 2, and then 1 plus or minus, that's the b value, 3. That's underneath the y value. Foci, I got to bounce back over to the x value. So that's going to be 2 plus or minus, the c is 2.6. The y value stays the same, 1. As long as I see that, you're good. But for a lot of people, that's kind of confusing to graph from. But if you're fine reading the points from that and graphing, that's fine. I like to write the 2 points I have. You're not going to be able to see that very well. So like I would write, oh, this gives me 6, 1, and this gives me negative 2, 1. I added, I subtracted, yeah.
Do we have to do like that plus or minus one if we just do the last two?
Like you just want to write these 2 first? That's fine. Yeah, if you'd rather write these 2 and not the plus or minus, I'm okay with that as well. So here I have 2, 4. And I have 2, negative 2. And here I have 4.61 and negative 0.61. So either I need all the black, I need all the blue, or you could show me both. That's what Zayden was asking, and I'd be fine with either. We do want to graph the center on these, not only because I want to see it, but it's going to help you understand whether you're on the right track. Because everything should be symmetrical. So if you start graphing and it's not symmetrical around that center, you know you've done something wrong. So my center, I start off at 2, 1. Then I go to 6, 1. And it's lined up with the center, so I feel good about that. Then I go to -2, 1. It's lined up with the center, and those points seem symmetrical, so I feel good. 2, 4. That's lined up. Feel good. 2, -2. That's lined up. Those points seem symmetrical. I feel pretty good. If I accidentally graph something wrong, maybe I just went here. I'm like, oh, something's wrong. They're not symmetrical. Oh, I didn't plot that right. So not only can it help you see if you made a mistake mathematically, but sometimes maybe you plotted something wrong. Yeah.
How's never mind.
Okay. I'm gonna draw this and then put my foci in there. I made a really good one last period, so of course this one isn't as good. Well, it's not bad. So let's see, 4.6.
Okay, mine's kind of good.
Was really pitched. There are my foci.
Yeah, I was excited. I was excited, boys.
That's what that was.
We should draw a line through the middle.
Mm-mm.
Okay.
You can if you want to,
It
as
just
the
feels
axes.
weird. I'm not going to. It just feels weird.
You
on the
can,
line.
because those are your axes. So if you want to draw axes through there, you're welcome to. Doesn't matter, one way or the other. All right, go back to your pink sheet. We're gonna knock out the hyperbola. Ideally, I'd like to do the hyperbola in the circle, but my guess is we'll just get to the hyperbola. Circle's pretty easy. We'll see.
Remember you said for people not to miss Wednesday?
I did.
There's so many people absent today.
All right, let's do the centered at 0, 0 first. So it's, I gotta go thinner. It's x squared, so this is off to the side, x squared over a squared. What makes it a hyperbola? Subtraction, so minus y squared over b squared equals 1. So the center is 0, 0. You can put it underneath. I just don't have room here. Vertices plus or minus a0. Points 0 plus or minus b. Foci plus or minus c0. Asymptotes y equals plus or minus. Which is it? I just didn't hear you. B over a. You're right. So b over a x.
So hard.
I just didn't hear you. All right, let's knock out the standard form, or the 0, 0 form, I should be saying, of the vertical one. Oh, if you want to call this one the horizontal, you can. Again, some of you may not need that. This one's the vertical. What changes? Good. So y squared over a squared minus x squared over b squared equals 1. Center's at 0, 0. Whoops. I know I'm going fast. I'll wait and make sure. I'll wait and make sure you're all caught up.
Dang.
I won't even say it. I'll just write it all down. And then what I would put at the top of the hyperbola is your equation, which is c squared equals a squared plus b squared. And I would put a squared is first. That's not how you would write that. So I'll let you get all that before I try and put the new part.
Wait, what did you just now say?
So I added this part up here.
Little
Okay, thank you.
scribbles.
So I put c squared equals a squared plus b squared. And then I put a squared as first. Because a squared is always going to be first. Whether y squared or x squared is first, a squared is always first. Okay, are we okay?
No.
Well, do we have it all written down? All right, so guess what? We're going to throw in the h and the k. So it's going to be x minus h squared over a squared minus y minus k squared over b squared equals 1.
I'm glad it equals 1 and not something fancy.
Yeah.
At least we
It's
have
going
that.
to equal something fancy.
At least we have that for us.
I already know.
What's the center? HK. And just like the ellipse, you take the opposite. So the vertices, I'm going to add it to the h value. So h plus or minus a, k stays the same. The points, the y value changes. So h stays the same. It's k plus or minus b.
Is it going to be H plus or minus C?
Yep.
B?
So the foci, foci is going to be h
Or K?
plus or minus c. K stays the same. Now the asymptote. So what's happening here is everything's shifting. So those asymptotes, they're shifting. So the line is shifting. So what's changing in the asymptote equation?
Slope. The plus.
The slope doesn't
the plus.
change.
The like plus.
The plus or minus doesn't
no,
change.
like at the end, like you do like plus.
What do we
something.
call that?
The B. The Y intercept.
The B, the y-intercept. So that's what changes. Oh my gosh, and to try and figure that out, it is a nightmare. And do we graph with that line?
No.
No, we just use the box. So we're not going to try and figure out the asymptotes. Good news, right? We're just going to put the slope. The slope stays the same. So we're just going to put m equals plus or minus b over a. And that's what you can use for any form, whether it's at 0, 0, or anywhere else from this point on. So you just need to know the slope, since we're not even graphing the line.
A.
Okay, let's do the other one. This one is going to probably be the easiest one to make a mistake on at the beginning because it's y minus k squared. And so that k comes first. And so it's going to be easy to forget to flip it around when you make your center. So y minus k squared over a squared minus x minus h squared over b squared equals 1. So notice the k is always with the y, the h is always with the k.
It's like the
Nope, the h is always with the x. You can think of it like that if that helps you. So the center is hk. I've never heard anyone explain it like that, but that could help some people. So the vertices, it's going to be h, then k plus or minus a. The points, it's going to be h plus or minus b, and then k. Foci, h, and then k plus or minus c.
What
And
are
then-
you saying?
And then the asymptotes, just the slope, y equals plus or minus a over b.
Whoa, seriously, what were you saying? She said the first thing about Hawkeye. Say what you were saying.
She's about as bright red as you
I'm gonna
usually
start
get.
crying. Well, just a second ago, she's like, best news ever. And I was like, Okay, tell us what you're gonna say.
I was saying caca.
Oh, you were trying to be like me and make a.
Yes.
Not successful. All right, go to your graph paper.
Bandwagon McQueen.
Fonzie and Lightning McQueen today.
What is one hyperbola you see? Let's do number 3. I agree. Subtraction.
Oh, you're a poet and you didn't know it.
Oh.
Number 3, you agree.
And this is a good one to do because it's also which way? Vertical, so up and down. So it's a vertical one.
She always does that, like it's gonna, like,
Started.
I don't know.
All right, so let's find the A and the B and the C first.
Wait,
I haven't started.
you're going to.
You're about to.
Okay, well just say wait. You don't have to say it all panicked.
It was panicky.
Match the situation.
Don't worry about it, sweetheart.
Don't laugh at her. Do not make her feel better about that. That's normal.
I did not.
All right, what's the A?
2.
So the A is 2.
No, it's not.
Yes, it is. The A is always first.
Yeah.
The B is 3. C
That's
squared,
confusing too.
I add those. So 4 plus 9, so 13. Thank you, Megan.
I'm just like dyslexic whenever I get rushed.
Okay, I will slow down. We're not going to get to a circle. I've given up on that hope.
It's almost time to go.
Hence why I said we're not going to get to the circle.
Pack up early as well.
Yeah.
No, we're going to finish this.
Yeah, let's go.
All right, we're going to need the center, the vertices, the points, the foci. I'll run out of room, so I'll put the asymptote slope over here. All right,
So much.
what's the
We
center?
need the asymptote.
You still need the slope of it.
Oh.
So what's the center?
1, 3.
Yeah, 3, 1 is going to be the common mistake. We got to make sure we start with the x. So 1, 3. The A is underneath the y. So the y is what gets changed. So 1 and then 3 plus or minus 2. Once you get that first one, then this is what I'm saying. It kind of bounces back and forth. So once I get the first one, then I feel like it's going to go pretty smoothly. 1 plus or minus 3. 3 stays the same. 1, 3 plus or minus 3.6. Asymptote, the slope, plus or minus. This is one that I do have to memorize, and it's just A over B. Reduce if you can. You can't here, 2/3. This is 1, 5. 1, 1, not -1. 4, 3, -2, 3. 1, 6.6. And 1, -0.6.
Oh my goodness.
These are so long.
I hate this.
Tell me how you really feel, Dakota. Again, that center helps you know if you're on your right track because you're keeping everything symmetrical. You're gonna get
Right track.
you're gonna get your box in there. Your asymptotes in there. Whoa, that did not go very.
language.
Oh my gosh. And there's your curve.
You guys gave me pity laugh.
So what we're gonna do is tomorrow we'll finish the notes. If you want to start working on any of those, you're welcome to. It is going to be an assignment that's due. Friday will be more of a work day to work on page 655, 3 through 8, and number 10. But I am also going to give you some problems on the 9-6 worksheet. There's still a question mark there. I forgot to erase it. I just haven't decided which numbers on 9-6 yet. I'll decide that tomorrow. I know at least Bailey, but maybe some other of you might not be here Friday, and so I can give you that worksheet tomorrow. But Friday will be more of a work day. We will have a quiz on Monday. Friday we will have a test. Monday's quiz, we will not be writing equations, we'll just be graphing. What?
It's not here.
Let's do tomorrow.
This homework is gonna be due eventually on Monday.
What homework?
So page 655, I'm sorry, I wrote it in the corner. Page 6, yeah, you can take a picture, sorry, I didn't say that. So page 655, 3 through 8 and 10. So it's not due until Monday, but you'll also have part of a worksheet to add to it. If you would like to start working, because I know it's a busy weekend, but you will have all of Friday to work. But if you want to start looking at some of them, obviously you can only do the ellipse and the hyperbolas. But if you want to start looking at some of them and you put them out of order, you're welcome to. Does that make sense?
Yep.
Okay. As long as you have that, you're good to go. Not due until Monday.